everyone. Today we are going to present our final project, which is about conditional lyric generation with fine-tuned GPT model generating emotional shift lyrics under syllable and rhyme constraint. Firstly, this is the introduction and brief overview of our research project. Firstly, the automatic lyric is difficult because the generated lyrics need to satisfy multiple constraints at the same time. And besides the basic requirement of the fluency, emotional control, and the structural alignment, we also want our model or the song to be particularly usable, which means that actually many of the previous music granted system are requiring MIDI or audio output. However, this kind of data is not always available. Therefore, our project focuses on text-based setting where we only use lyrics and metadata to train our model. So the primary goal of our research project is to, when given a source song and a target motion, we want our model to generate new lyrics that preserve the original structure of the song while it can change the emotion and desired tone. And here's the related work that we use in our project. There are mainly two directions in the previous research. The first one is about music grounded lyric generation, where the model uses mainly melody or MIDI information to improve the match between music and the lyrics. These methods are effective, however, they require aligned audio or MIDI data, which is not always available to us. The second is structure control text generation, where the model uses control codes to guide rhyme, meter, or line length. However, these works usually focus on poetry structure, and they do not fully combine the lyrics metadata, such as emotion, genre, and tempo. So our projects actually sit between these two directions. We do not use the MIDI or audio data, but we preserve the lyric structure through text-derived syllable and rhyme control. We also add emotional control and automatic re-ranking to select the best candidates among our generated results. And here is the general pipeline of our research projects. First, we start with an input source song. We use the original lyrics and structure as our reference. And then we extract the lyric structure from the source lyrics. So specifically, we estimate the syllable count for each line and derive a rough rhyme scale. For example, if the word ends of line 1 and line 3 rhyme, then they might be assigned as the same rhyme group. Third, we build a conditional prompt. This prompt combines target emotion, genre, and the tempo which we want to include in the generated song. In other words, the prompt tells the model that we are not only caring about the structure, but we also care about the emotion we are generating, and also which structure we need to follow under that goal. Fourth, we fine-tune the GPT-2 model, where we add special tokens such as the emotion tag, the genre, and the tempo. We use this method to allow our model to learn how these control signals are related to our final lyric text. Next, on the fifth step, during the inference process, the model does not generate only one output. Instead, it generates multiple different candidates, and then we use the ranking process at the last step to choose the highest score model and use that model to generate as our best candidate for our song generation. And here is the model and the re-ranking algorithm we are using. So firstly, we use the conditional GPT generation. We use GPT-2 to fine-tune the control tokens for different features, so you can generate lyrics based on the structure prompt. Secondly, we use the distilled emotion classifier to evaluate whether each generated lyric matched the target emotion, such as given a joy probability when the target emotion is joy or happy. Third, we also use multi-metrics to re-rank our candidates. Since the model generates multiple candidates, we use the weighted score for each song or each candidate by scoring their syllable alignment, rhyme similarity, emotional probability, and their fluency. So the candidates with the highest score will be our final selected output.
Okay, so I will talk more about our evaluation approach. So in this text, we cannot apply a simple matrix to evaluate the results because there is no single character rewritten lyric. If a generated lyric uses different words from the original but still preserves the structure and target emotion, it should still be considered successful. So we use a weighted scoring function, as you can see here, and there are 4 components, which is the score of syllable, the score of rhyme, emotion, and fluency. And the experimental part, which is the main focus of the research, we use data space from the Kaggle website, which contains 500,000 unique songs with format data, and including features like the tempo, loudness, key, instruments, and so on. And we mainly use tempo, emotion, and lyrics. In terms of models, we use these 3 types of models as my teammate has explained before. So the whole experiment is not just a pure language generation experiment. It combines neural generation, emotion classification, and rule-based structure evaluation. And this slide summarizes the variables we set for the experiment. We totally run 4 rounds of the experiment, and in round 1 we used a relatively smaller training setup. It had shorter structure input and shorter maximum sequence length. Therefore, we treated it as our baseline. And for the round 2 and round 3, we increased the amount of training data and expanded the context length. This allowed the model to see longer lyric structures and more complete training examples. We also generated more candidate lyrics during the encoding part. And for the round 4, we used the largest training scale. Although the number of approaches was reduced back to 2, round 4 still had the largest data set, a long context window, and the most candidates for re-ranking. This model is our final and strongest configuration. And here is our result. So for the emotion classifier, the overall performance is quite stable across all rounds. As we increased the training scale, the classifier did not become worse. Instead, it stays consistent and slightly improved. And one thing that worth to notice is that the models struggle more with the smaller categories, especially like surprise, emotion. This suggests that the classifier is useful, but it still reflects the imbalance in the data set. And as you can see, the round 2 and round 3 respectively focused on emotion and syllable. And the best one, which is the round 4, has a relatively higher score for all aspects and has the largest and uses the largest data set.
And here is a brief example of our generated song comparing with the old lyrics. Here we changed the emotion tag and focus from sadness to joy. As you can see here, actually the generated song faced a problem of fragmented output. Although it can generate certain lyrics and songs with the certain emotional tag, however, it still faces several limitations. And here leads to our conclusion and the future works or directions of our project. Firstly, the generated lyrics contain the fragmented one-syllable line, and some outputs can sound generative. Also, since we did not use MIDI or the audio alignment, our rhythm control is only based on text-derived syllable estimates, and we also did not include human evaluation, so the current evaluation process mainly rely on the automatic metrics. For the future direction, we plan to add more post-processing to fix the sharp fragmented line, and also improve the syllable and rhyme control, so that when we are including the human evaluation, we want to explore more melody and MIDI-based alignment. Overall, our research shows that the fine-tuned GPT-2 model with the emotion-aware and structure-aware re-ranking can generate more control lyrics, but extract musical structures still needs stronger and further post-processing and better evaluation metrics. And here is our project. Thank you for listening.